Why is specific heat at constant pressure, CP, key for isobaric changes? Imagine you're heating a pot of water on the stove. As the water heats up, it expands and changes in volume. Now, think about how much energy you need to add to make that happen. That's where the concept of specific heat at constant pressure comes into play. It helps us understand exactly how much heat is needed when pressure stays the same. In an isobaric process, pressure remains steady, but the volume of the gas or liquid can change. When you add heat, part of that energy goes into raising the temperature, but some also goes into doing work by expanding the substance. The key is that the heat added doesn't just increase internal energy but also causes the system to do work. That's why we need a property called specific heat at constant pressure, which accounts for both these effects. Specific heat at constant pressure, or CP, tells us how much heat energy is needed to raise the temperature of 1 unit of mass of a substance by 1 degree when the pressure stays fixed. It's different from the specific heat at constant volume, which only considers heating without any change in volume. Because in an isobaric process the volume can change, CP includes the energy used for that expansion work. Think of it like this. When you heat a gas at constant pressure, some of the heat goes into increasing the internal energy, and some goes into pushing the boundaries of the container outward. The amount of heat needed for this combined effect is directly related to CP. This makes CP a very useful property for calculating how much energy is required during processes like heating air in engines, boiling water, or chemical reactions that happen at constant pressure. Another reason CP is so important is that it relates to a property called enthalpy, which combines internal energy and the work done during expansion. Changes in enthalpy tell us how much heat has been added or removed at constant pressure. By knowing CP, engineers and scientists can accurately determine how much energy is needed to change the temperature of gases and liquids during these processes. Without CP, it would be nearly impossible to predict how much heat is needed to raise the temperature of a substance when pressure stays the same. Whether it's designing engines, heating systems, or chemical reactors, knowing CP helps us understand and control energy flow. It makes calculations straightforward and reliable, ensuring processes run smoothly and efficiently. In summary, CP measures the heat needed to increase temperature at constant pressure, including the energy for expansion work. Since isobaric processes involve volume changes, CP is the perfect property to analyze these changes. It's directly linked to enthalpy, which represents heat transfer at constant pressure. Using CP allows us to accurately determine energy requirements and temperature changes during these processes. That's why CP is essential for understanding how gases and liquids behave when pressure stays the same while they heat up or cool down.